The threshold was crossed long before anyone understood the scale of the operation. On March 1, 1942, the Australian light cruiser HMAS Perth went down fighting in the Sunda Strait. The vessel was a massive combat machine, measuring about 555 feet from bow to stern. During a brutal night engagement, torpedo impacts breached the lower engineering spaces. The warship rolled over and settled onto her port side. 353 men, including Captain Waller, did not survive the action and the sinking. For decades, the wreck rested in relative silence at a depth of about 115 feet, or roughly 35 meters. When it was found in the 1960s, the structure was still largely recognizable as a warship, sealed in a shallow coastal environment. But it was never perfectly untouched. Over the following decades, bells, fittings, and other material were removed, and smaller acts of souveniring scarred the site before the industrial-scale damage began. Then the parameters changed entirely. In 2013, suspicious surface activity was reported in the area of the known wreck site. Local maritime traffic and recreational divers observed commercial salvage barges holding station near the cruiser. These were not small, independent boats. They were industrial vessels equipped with heavy cranes and grab-style recovery gear. The surface observation confirmed an active, ongoing threat to the site. A systematic extraction operation was tearing into the hull. The objective was not the recovery of historic artifacts. The target was the steel itself. The motivation behind the destruction was rooted in the specific metallurgy of the 1930s. Before the first atomic detonations in 1945, steel was largely free of the man-made fallout contamination that later became measurable in the atmosphere. After atmospheric nuclear testing began, tiny traces of artificial radionuclides entered global industrial systems. Any steel forged after that period required atmospheric air to feed the furnaces, introducing microscopic levels of radioactivity into the metal. Modern steel is perfectly safe for structural use, and for most applications its radiation signature is irrelevant. But for some ultra-sensitive radiation detectors, calibration chambers, and shielding systems, older low-background metal can still be valuable. Sunken pre-atomic vessels are one possible source of this material, alongside other pre-nuclear stock and specially produced low-background alloys. This material is known as low-background steel. The light cruiser resting in the Sunda Strait represented thousands of tons of valuable pre-atomic metal, though its 6,830-ton displacement was never the same thing as recoverable scrap weight. One possible incentive behind the destruction was the market for low-background metals. Another was the simpler value of ordinary non-ferrous and ferrous scrap. Either way, the war grave had become an industrial mining target. The sheer physical size of the surface barges indicated a highly mechanized operation. However, the exact identity and origin of the commercial vessels could not be proven from surface observation alone. Observers could see the cranes moving and the barges holding their geographic position, but they lacked the legal authority to board, inspect, or impound the offending ships. Furthermore, the surface view offered no distinct forensic proof connecting a specific barge to a specific piece of torn wreckage below. It is a fundamental rule of maritime investigation that surface proximity does not equal legal proof of illegal extraction. The vessels carried no clear company markings and operated in a legal gray zone. The observation verified the threat, but it provided an unbreakable proof ceiling. Without direct physical evidence tying the reported surface activity to damage on the seabed, immediate enforcement was difficult to trigger. Surface watchers were essentially paralyzed. They could only document the geographic presence of the industrial platforms while the underlying structure was systematically dismantled. The situation presented a severe operational boundary. The shallow depth of 115 feet, which had originally made the wreck accessible to basic exploration, now made it completely vulnerable to blind mechanical extraction from above. The industrial scale of the threat forced a complete shift in international perspective. It was no longer a question of passive heritage management. It was an active crisis. The physical reality of the site was changing daily. Entire sections of the heavy combat vessel were vanishing from the seabed. Stopping it would require a coordinated logistical and legal effort to survey the damage and document the mechanical destruction on the seabed. The overarching question remained open. Could the international community intervene and establish a legally binding baseline before the massive wreck vanished completely? The window to legally secure the site was rapidly closing. The sheer geography of the loss created an immediate and crippling administrative barrier. The sunken vessel rested entirely within foreign sovereign territory, creating an immediate jurisdictional tangle. Under established international maritime principles, a flag state retains a continuing interest in a sunken commissioned warship. However, the coastal state controls access, permitting, and enforcement in its territorial waters. Australia retained a sovereign interest in the warship, but it could not unilaterally send patrol vessels into Indonesian waters, arrest salvage crews, or independently regulate access to the site in the Sunda Strait. This overlap of ownership, sovereignty, and enforcement slowed any response and gave the salvage operators room to keep working. The looters operated comfortably within this legal gap. Local regional authorities often lack the specific maritime heritage mandates necessary to impound massive industrial barges, solely for removing undocumented scrap metal from an underwater site. Any uninvited attempt to approach the coordinates and disrupt the surface operations would constitute a major diplomatic violation of territorial sovereignty. The only legally viable countermeasure was a formal bilateral agreement, even as each month of diplomacy allowed more structural mass to vanish from the seabed. Unilateral enforcement would permanently fail. Instead, they focused on joint scientific cooperation as the primary legal mechanism to work inside the sovereignty problem. ANMM began working closely with ARKENAS in 2014, after reports of illegal salvage on Perth, Houston, and other wrecks in the region. In August 2015, the two organizations signed a memorandum of understanding to research and, where possible, protect sovereign warships lost in Indonesian waters. The definitive field breakthrough came later, when that framework supported the Joint Dive Survey in 2017. By operating under a joint scientific mandate, the combined international team was successfully granted the required official permits to approach and assess the wreck site. The mission was non-intrusive and survey-only. The newly signed joint mandate provided the critical authorized access needed to document the vessel's current physical state. It successfully transformed an inaccessible sovereign target into a legally sanctioned scientific zone. Those permits authorized remote sensing and visual mapping only, forcing the maritime archaeologists to build the forensic case with sound waves and digital imagery alone. This highly disciplined operational restraint was absolutely essential to maintain the diplomatic trust established by the bilateral agreement. Any violation of the strict non-touch mandate would immediately revoke the operational visas and shut down the entire collaborative effort. The team mobilized to the exact geographic coordinates equipped with the necessary governmental authority, fully prepared to map the zone within these rigid parameters. The invisible administrative boundary had finally been crossed, replacing a stagnant enforcement problem with a permitted scientific mission. The Memorandum of Understanding and Indonesian research permissions gave the combined team the limited legal right to look, but the natural marine environment retained absolute veto power over what could actually be seen. Diplomatic access is merely paper. Deploying delicate remote sensing equipment into the turbulent, fast-moving water of the strait would instantly trigger an entirely different kind of physical limit. The next limit emerged at sea. When researchers first attempted to quantify the destruction in 2016, they relied on remote acoustic survey methods. A specialized survey vessel used multibeam sonar and related acoustic mapping to build a broad three-dimensional impression of the massive steel target. In a calm environment, these systems can reveal the wreck's overall shape, major absences, and large structural anomalies without a single diver entering the water. However, the geographic reality of the Sunda Strait actively destroyed the required acoustic geometry. The area serves as a massive hydrodynamic funnel between major landmasses, generating extreme currents and highly volatile weather patterns. During the 2016 mapping attempt, severe weather compromised the operational window. Heavy wind, surface chop, currents, and poor sea state degraded the acoustic images. A sonar system relies on a stable two-way transit. The acoustic pulse must travel down through the water, strike the dense steel of the sunken vessel, and reflect back to the surface receiver. In these conditions, the water column and the moving survey platform degraded the return data before it could produce the forensic clarity the team needed. The returning acoustic data raised serious concerns, but it could not resolve them. The survey suggested that major disturbance might exist on the seabed, yet the images were too poor to explain the damage conclusively. The acoustic data could not definitively prove whether the hull was suffering from natural structural collapse over time, sediment effects, or systematic mechanical extraction by commercial salvagers. It could not provide the precise visual evidence needed to measure the missing steel with confidence. In legal terms, the evidence still fell short of the threshold required for enforcement. The remote sensing failure established a hard environmental limit. That loss of clarity forced a critical operational pivot. The joint 2017 expedition therefore left remote surface mapping behind and shifted to a direct visual archaeological dive. If the sound waves could not pierce the turbulent water, human eyes and high-definition optical cameras would have to descend into the darkness to manually document the damage. The case would now rest on optical evidence gathered by human operators, exposed to the same severe currents that had agitated the surface. The divers had to maneuver bulky camera housings through the fast-moving water, while strictly maintaining their rigorous non-disturbance permit limits. Every photograph, every minute of high-definition video, and every mapped observation had to be systematically recorded, tied back to the survey plan, and strong enough to support a formal protection case. The optical data had to succeed exactly where the acoustic data had failed. The team expected a deteriorating but still cohesive warship. At the bottom, they found a mechanical slaughterhouse. Interim assessments indicated that only about 40% of the massive light cruiser still survived in recognizable form on the seabed. When the combined archaeological team systematically mapped the primary structure, they documented something more precise. Approximately 60% of the starboard hull plating had been removed. The visual evidence showed that corrosion and battle damage could explain only isolated damage, not the scale of catastrophic industrial dismantling. The mechanics of the extraction were brutally simple at the industrial scale. The missing stern, armor belt, hull plating, turrets, and machinery pointed to substantial equipment, probably including a crane-operated grab or claw mounted on a large barge. Smaller signs of salvage also remained on the site, including lifting gear and hand tools. The operation was not a careful archaeological recovery. It was a destructive commercial removal of metal. This aggressive removal left an undeniable forensic signature across the site. By mapping what was gone, what was still attached, and what had been stripped from the internal compartments, the visual survey separated modern salvage from the original combat loss. A torpedo strike from 1942 could account for concentrated blast damage and localized deformation. It could not account for the later disappearance of the armor belt, large sections of starboard hull plating, internal decks, bulkheads, turbines, boilers, propeller shafts, and gun turrets. The distinction was now forensic, not interpretive. At the forward section, the optical mapping revealed that both Mark 21 turrets, A and B, were completely absent. These were not superficial deck structures. Each turret weighed more than 95 tons, proving access to substantial heavy equipment after 2013. Farther aft, the stern section, propeller shafts, and after turrets, X and Y, were also gone. While the external optical mapping successfully quantified this staggering loss of mass, the sheer brutality of the extraction process created a severe local constraint. The repeated removal of heavy structure had critically compromised the remaining strength of the cruiser. With much of the starboard side missing, the surviving port side structure was asymmetrical and weakened. Massive sheets of torn steel and deck sections were beginning to peel away from surviving bulkheads. The archaeologists therefore treated the interior as a hazardous, non-disturbance environment. But the torn open hull also revealed the scale of the internal stripping. Perth's internal compartments had been systematically salvaged, with many bulkheads, decks, and fittings removed. 3 of the 4 Parsons geared steam turbine sets, 3 condensers, and 4 Admiralty Type 3 drum boilers were gone. The visual assessment of the coherent main hull therefore answered the core question not only outside the ship, but deep within its machinery spaces. The wreck was not merely scarred, it had been gutted. The spatial geometry of the wreckage scattered across the surrounding seabed formed a massive forensic clue. When heavy material was removed, the process did not leave the site clean. Loose fragments, torn plating, frames, cables, fittings, and displaced artifacts were left across and around the surviving hull. The archaeological team shifted focus away from the surviving central architecture and began a methodical visual sweep of this detached perimeter. Mapping this debris helped the team separate the 1942 combat destruction from the modern mechanical removal. A combat torpedo strike delivers extreme energy into a specific hull section. The later debris, stripped compartments, missing machinery, and displaced material showed a different process. Commercial salvage had cut, pulled, lifted, and disturbed the wreck long after it sank. It did not need to trace every lift path perfectly. The separation between wartime blast damage and later mechanical disturbance was enough. However, the chaotic zone carried a new hazard. The mechanical stripping had breached or disturbed ammunition spaces inside the warship. As a result, significant unexploded ordnance was exposed among the torn steel fragments. The divers observed 4-inch projectiles and at least one 6-inch projectile resting on or near surviving hull plating. Some of this historic ammunition carried explosive and chemical hazards associated with materials such as lyddite, amytal, and picric acid, and at least some items showed signs of toxic leakage into the surrounding water. The presence of exposed ordnance created a hard safety boundary for the survey team. The scattered munitions restricted how closely divers could examine some areas while mapping the detached evidence. The archaeologists could not move hazards simply to gain a clearer view of the seabed. They had to document the explosive geometry exactly as it lay. Despite this severe operational boundary, the visual mapping of the displaced field achieved its primary objective. The off-hull fragments showed how upper deck destruction had been mirrored by a hazardous blanket of drop material in the mud. The archaeological evidence of the destruction was now irrefutable. Yet the physical survey merely secured the forensic data. The scientific mission was over, but an ironclad underwater map without binding international enforcement guarantees absolutely nothing. The next step was turning that evidence into enforceable protection. Before the expedition, the commercial salvage barges had operated with near total impunity in a busy commercial waterway. The visual mapping mission fundamentally altered this paralyzing dynamic. The resulting joint dossier of geolocated optical data and precise structural measurements successfully converted underwater destruction into highly actionable legal evidence. The record could now support a formal protection decision. Diplomatic channels and regional enforcement agencies could no longer treat the missing mass as ambiguous. Armed with the rigid scientific documentation provided by the dive team, the government took an unprecedented and historic administrative step. In 2018, Indonesia inscribed the area around the sunken cruiser as a maritime conservation zone, reportedly the nation's first zone of this kind. The joint scientific effort directly supported that binding legal heritage protection. The coordinates were reclassified from a vulnerable management problem into a protected maritime zone with a clear legal basis for care. Despite this monumental administrative victory, the sheer logistical scale of the prior commercial salvage left a major forensic void in the historical record. The exact total weight of metal extracted during the multi-year operation remains undocumented in the available public record. The visual mapping successfully quantified massive missing structural volume, but investigators have not publicly traced the final destination of the stolen material. The chaotic nature of the underwater destruction, combined with the lack of clear commercial identification on the heavy surface barges, means the fate of the forward gun turrets, the armored plating, and the machinery remains uncertain. Whether the material entered ordinary scrap channels, specialist low-background metal markets, or both, the supply chain absorbed it before legal protection could be finalized. Indonesia's Maritime Conservation Zone now contains a core area around the wreck and a larger limited use area. In the core zone, activities are tightly limited to surveillance patrols, research, and non-extractive development and education. The wider limited use zone can allow other regulated activities for local communities, including pilgrimage, water-based tourism, fishing, and aquaculture. The bilateral framework also gives both nations and regional authorities a clearer basis to monitor the protected area, manage permitted activity, and respond to future threats. The operation in the Sunda Strait stands as a defining example of modern maritime heritage enforcement. It was not a story of successful heavy salvage, daring recovery, or dramatic at-sea intervention. Their restraint and forensic discipline helped forge a durable administrative shield. What remains of the cruiser now proves the larger lesson. precision mapping and disciplined diplomatic cooperation can still secure a historic vessel after catastrophic loss.